Hello guys, I am Riganko Haldar and I am from BHU, and this is my second internship task from CodeSoft. This is IMDb movie dataset, EDI and prediction problem. So I completed my tasks in Jupyter Lab and Python. At first I import the necessary library, that is NumPy, Pandas, Matplotlib and C1. Okay. And then I import my dataset from the Kaggle website, and this is my data, and data type say 15,509 in column. So 15,509 is rows with 10 columns, and the column names is names, year, duration, genre, rating, votes, director, and actor 1, actor 2, actor 3, and this object. At first we check the any null value of this dataset. This code data dot is na open parenthesis and close parenthesis and sum. Then year has 528 nan value and duration has 8269. So this dataset contains the big nan value. So we drop this nan value, and this column is data dot drop na in place is true. So dropped the missing value, and then we check the null value, then it will 0. So our dataset is free from the null value. Okay, and the shape is reduced to 5,659. 10. This null value is removed from the dataset. Okay, and data info, where name is non-null and everything is non-null value, and object and one rating is float value and name is object. This object only rating is the float value. Okay, so at first we convert the year column the numeric, so non-numeric column to numeric column. So we use the pd.numeric data year extract d open parenthesis d plus, that means we remove this parenthesis, and errors is course, and we convert the year column non-numeric to numeric. Okay, and data to info, the integer value, year column will be integer value, and we draw a line plot of the annual movie release over the time corresponding to year. We use SNS C1 SNS line plot data year and value underscore count. That means we count the number of movies with respect to the year, and dot sort index we sorted this count of the dataset, then minimum to maximum, and tick underscore positions, that's the range of the x minimum range of the x level is 1931 and maximum of the 2021. Okay, and this graph, and this is my graph. So in 1939 is the minimum, and highest value we picked is 2016 to 2021 is the highest number of released movies. So this is increasing trend, but after 2016 and 2021 this rate is decreasing. Okay, and we draw a blocks plot over the year and count. So this is the first quartile, this is the second quartile, and this is the third quartile. So difference between the first quartile and the second quartile is maximum than the difference between the second quartile and the third quartile. So this is the negatively skewed distribution. Okay, this is the negatively skewed distribution, and the median is 2002. The median 2002. Okay, and we draw the hist plot. So this is a negatively skewed distribution hist plot. Beans is 50, so we mm, beans 50, KD is 2. This is draw a probability curve and this. Okay, then we draw the probability plot of the probability plot, and this is a QQ plot, and this is a QQ plot. This is not a normal distribution because this is not exactly the line, so it differ from the this straight line. So this is not normal distribution. Okay, and the duration, we also convert the duration from the numeric column, because duration is the object, but we convert to the duration in the numeric column. So similarly, this we use the previous one code and this, and we draw the also a line plot, the average movie duration trends over the year. So average movie, so average duration. So in this line plot, we see that uh, the duration of the movie is very high in 1931. Okay, and 1936 up to 2026, this is similar, and after 2021 to after up to 2021, this is decrease the duration of the movie. Yes, the decreases. This is similar to the duration of the movie time, and this is the blocks plot. There, the difference between the first quartile and third quartile, and difference between the first quartile and the second quartile is the same. So this is quite a symmetric distribution, and and we this is the outlier. So we removing the outliers, the interquartile range, and this code. Interquartile range is the first quartile minus 1.5 multiplied into interquartile range, and we uh, extract whose elements are the less than the lower bound and uh, upper bound. So we extract this the data, and we remove this data, and we mm, remove the outlier, and this is our uh, remove the outlier of the average movie duration. The duration. Okay, and SNS.kd plot, we plot a probability distribution, and this shows the normal distribution. Actually, this is the similar. This is trend is similar. So is the overall, this is the normal distribution, and its mean is correspondingly 100 to 150 between. Okay, and our next is January. So we January column, we got our January column, and we create a data frame, the January column, expand the January column, and this January's data January.str.split expand is true in the inverted comma, and we calculate the frequency of the January column in this code, and we show this drama each 1954, and and minimum is the western one. Okay, highest is drama. Okay, and we plot this movie January corresponding to the January, and this count is drama is very high, and this will be small. This is the line plot. Okay, and this is the votes. Similarly, we create a data frame of the votes previous one, and this is okay, and this is the directors data directors value count. Uh, the director David Dhawan 41's movie, and minimum is Mujit Singh. And we draw a bar plot of the director, and this is the highest one is the David Dhawan. This is highest one. This is 41, and minimum is Mujit Singh, Salar Sheikh, Vicky Bharadwaj, Randeep Jha. This is the bar plot. Okay, the bar plot code is uh, sns.barplot directors.head 20. So we actually take the 20 first 20 rows of the data column, sorry, of the detector column, and this is its color is the each color of the black is black and palette is the reddish. Okay, and this. Okay, and we actors similarly there are here we have three actors: actors 1, actors 1, actors 2, actors 3. So we create a column with three actors, and then this is, yeah, we concat the actors 1, actor 2, actor 3, and drop now. So we drop out the non value and value counts the actors, and we see that Mithun Chakraborty is the highest engaged with the movie, the 160 movie, and this Amitabh Bachchan is the second one, 158, Dharmendra 146. And we similarly we create a bar plot, and the highest one is Mithun Chakraborty and Amitabh Bachchan, Dharmendra this, and this is the code is sns.barplot actors.head, and we similarly we take the 20 rows of the actors column, and this is the previous one as, and then we create a new data set. Actually these are the categorical data. Okay, so these are the categorical data. So at first we convert this the numerical as the from the categorical data. So we use this column cat.codes. That means this encodes the categorical variables to numerical. That means that it returns a new series of the numerical codes corresponding each category in the original data. Actually, in original data, it gives a new numerical value for the corresponding the different categorical data. And this is my code, and this generis, this is the numerical value to, so this is the categorical value convert to the numerical value. Directors, the categorical value convert to the numerical value. And the it we convert this data for using our next step. This is the uh, fitting a model. So we create this type of uh, encoding. Okay, and sns dot box plot of the generis. This is also a negatively skewed distribution. Actually, the difference between the first quartile and second quartile is the higher than the third quartile and the second quartile. So this is the negatively skewed. This is the generis and directors. This is also a positively skewed distribution. Okay, this is actors. This is similar. This is the normal distribution, symmetric distribution. Okay, and hist plot of the movie rating. We plot a hist plot of the rating of the movie, and this shows a skew slightly positively skewed distribution. Sorry, this is a slightly negatively skewed distribution, and this, yes, slightly negatively skewed distribution. Okay, and there is the outliers. So we remove the outliers in this code, the previous one, and rating. This is the float variable. This is the float variable. So the main concern from the fitting variable, actually the rating is the uh, dependent variable, and this is the float variable. So we see these characters of float variable. So we use the linear regression model. Okay, and we see the after my works. Okay, this is the rating corresponding with float. We draw uh, draw line plot with votes with corresponding the rating. So the votes is very high with actually six, eight ratings. So this is votes very high, 8 ratings. So most of the people gives the 8 rating, and minimum is this. Okay. And next task of my work is the fitting the dataset with appropriate model. So we use the linear regression model. So we import the necessary library scalar.model model trains test list and import linear regression and mean square error. Okay, and we detect the independent variable, that's the years, duration, votes, generis, and director actors, and we test, and our dependent variable is the rating. Okay, we import the stat model ACI SM, and we feed a OLS regression model. Okay, and the least square method, and this is the R square value 9.5, 0.9.5, and this is the probability value, this is the 0.5.56 and 0.117. So this is the greater than the 0.05. So we remove the directors and actors column. Okay, we remove the director and actor columns. So that's our result. So here duration board generates with corresponding the zero value. This is the probability is less than 0.05. So okay, or null hypothesis. Okay, so very small the residual this 1.334487, the residual, and x train, and we split the train and test in this color, this code, and the test size is 0.2. This is the 80% 20% rule, and the random stage is 88. Okay, and the train data is the 4505, and test data is 1127, and we put the linear regression and predicted value 5.37 and 6.0. This is the similar 5.2 and 6, and we plot a histogram of the residual, and this look like a normal distribution with zero mean, and this is a the error is the normal distribution. So we put the linear regression because this is the assumption of the normal distribution. Okay, this is my